Okay, quick video on an update of what I've been working on. A little bit of a sidetrack. I saw a really interesting project online called TF Jam, Shooting Hoops with Machine Learning. And I went ahead, since it involves Unity and TensorFlow, I wanted to learn more about this project, and one of the really cool things about it is it uses a raw, or what I call just a regular TensorflowSharp model. This project does not use the ML infrastructure that comes with Unity. It does require TF Sharp Unity plugin to be installed, but I went ahead and got more involved with it. It does use TensorFlow JS, TensorFlow JavaScript, and I am not using that. I went ahead and converted this project over to use Keras. Keras with the TensorFlow backend, and that's kind of how I have been doing stuff. So here's the link. If you just want to go and try to recreate what this guy's already done so he gets full credit, what I did do is create a GitHub of TensorFlow, a jam clone. And here's the link above. I just got through uploading this thing, and I'm going to go into a little bit more detail on how to get the project up and running. But to see what's going on, I'm running Unity 2018.1.4, and I have already installed the TensorflowSharp plugin on this project. So, and I have this in the instructions, but essentially what you're doing is you pull this project down from my GitHub, and after you install the TensorflowSharp plugin and run the project, you should see something like this. Now, I am still in the process of trying to develop the TensorFlow, or the Keras model, to better perform, and I did not get the same results with the model that the person had on his site. So this was just really fascinating to me. I'm moving the cursor around, and as you can see, it's not doing a very good job, not as good as the other person's model, but I think this is a great project for people that want to do C# and TensorFlow and Keras, machine learning, and not necessarily use the machine learning pipeline and the model architecture that comes with the ML examples. This is kind of a lighter weight way of doing things, and I like that because I might have 5 or 10 or 20 of these TensorFlow models running in C# that do different things, that are trained to do different things, and this is just a really kind of interesting example. So I spent more time, if you try to download the person's project and run it, it didn't run cleanly. I had to actually rebuild the scene. It didn't import correctly. Different versions of Unity, and Unity just has a hard time figuring out how to go between projects, but we were both running 2018. So to give you kind of a breakdown of what's going on in this project, the main thing is this player, and which is just has this player controller which just basically moves this guy around. The ball spawner is the one that has all the brains in it, and it has to these transforms have to be set up right, and that's what was broken. The hoop wasn't a prefab, it wasn't showing up in the original project. I have also added a couple of things trying to debug my model. The other thing I added to the project is you can turn on training, and basically what you see down here is every time this thing shoots and makes a shot and it scores, that gets written out to a CSV file. So it's always doing that anyway. The difference between this button right here is whether it's randomly, I guess we can do it right now, whether it's in like training mode. So now what's supposedly going to happen is we are building a data set now for to build our model off of, and as you can see right here, it's not making any shots, and I've let this thing run for probably 20-30 minutes to get some data. And there might be some more elegant ways to have this guy move back and forth and to get your information. So the other thing I put together was a whenever you're doing Unity or doing Python with TensorFlow and Keras, most of the projects you'll see are going to use a Jupyter notebook. And if you're not familiar with this, you probably need to get familiar with it pretty quick. I provide some batch files. Once you get Python and Python 3.6 installed, it should install Jupyter for you. It makes sense to have that Python installation in your path so you can run the Jupyter notebook command from anywhere in your directory, and that's what I do. I have a batch file that does that for me. Jupyter comes up, and then what it will do is it will immediately load the browser and let you come into the page, and it'll show a directory of the contents of where Jupyter Notebook is running. That's why you have to use batch files to put it in the directory you're running. So when you click on IPYNB file, you get this cool little web page, and this is where a lot of the magic happens. To run in Jupyter, you're going to have to go online and learn a little bit more of how it works, but basically you hold down shift and then you hit enter in a cell, and it will run just that cell. You can see where you can add cells, you could delete cells. So this is just Python code that's running in each cell, and it ran the first one. You didn't see any errors because it's already running. I've obviously got TensorFlow installed. I'm using a GPU version. I won't be going in any details on how to do that here. So when the Unity project runs, it's going to recreate this file each and every time in the main directory. And what I've done is added some Python code to copy that file over into our current directory, and also to load it into using Panda into an array. This code right here is going to change. and this is why I think this is a great project for people that want to get involved with machine learning and data modeling to look at, and especially with regards to Unity. Because I'm going to go into details on how you have to clean the data to get it to where a model, a Keras or TensorFlow model, can run against that data and train and work properly. You also you'll see that I've got Matplotlib up in here. The main thing is if you don't have all this stuff installed, it's not going to work. Matplotlib is kind of tough to get installed on Windows 10. It seems to do with pip install pretty good, and I talk about that on what you need to do. So yeah, this didn't format right, so I'm going to have to come back in here and clean this up. Sorry about that. So anyway, this is what about 350 shots looks like, and what you will start learning with Python and NumPy and things like that is how we are going to build a model that is going to fit this curve right here, and that's going to be our shot model. And that's actually this data is what was used to train the model that was running in Unity right there. So as you can see, we have some what they call outliers, and as you can see, this data has been normalized from 0 to 1, from 0 to 1. This is a really confusing thing for me. It's still confusing how you have to normalize the data before you can train the model. Or certain types of models, but then what do you do when you need to convert that prediction back out? So anyway, I've got some newer code that actually is going to go in, and it's going to do some standard deviation and mean. We're going to do some cleanup on this data. Some of these shots right in here, this will screw the model up when it tries to fit this curve. So anyway, the project, I think it is a great example to give to people. The version that the gentleman has on the TF Jam, he runs up 2 lines of code in JavaScript, TensorFlow JavaScript, and then there's some kind of magic that happens, and the model's created, and it turns out it's a Keras model, and he has to do a conversion on it using some tools. Well, I have to do the same thing, so I supply this whole notebook that kind of walks people through what you have to do to go from Keras to building your model, to running it, to exporting it, and then get it to run in Unity with TensorflowSharp, and the other black magic, which is these names that you need to give to your layers, input and output, so you know what values to extract inside of the C# code, and I'll show you that for you. But this is a very simple model that I found online, which was just a non-linear regression model, and this is where we compile it, and this is where we run what the Keras calls fitting, which is basically doing the training, and then at the very end we print it out. So you can kind of see it was trying. The red dots are the predictions, and the blue dots are the original data that we had up above. So this is the one-liner that you call on the model, and this is why I like using Keras, because it's really simple, but you can build elaborate models pretty quickly. So these outliers around here need to get pulled out. Obviously this model's bending down and trying to come back up. These aren't necessarily outliers up in here, but they're not, you know, within the nice curve that I want. I've got another version of this model that's a little bit smoother, and I've gotten at least rid of some of those points. So this is our wonderful model saved. This is going to save the model in a Keras format. And then I went online and I found a wonderful Python script that goes from Keras to TensorFlow. And I need to give credit to those guys. This is a pretty big script right here, and it's hard to follow. These are just previous errors because I didn't run the. I was basically adding the this code in here. What you have to do with Python notebooks or Jupyter notebooks is that you can run this cell, and then you can run this cell, and then you can run this cell. But if you open the notebook again and you try to run a cell that needs values from things that were created by the cells up above, it'll fail. So then you'll get things like you get here because the model doesn't exist. Because I just wanted to run this one line of code. So you have to go up to the very top, and that's usually a good idea. You run this one, this one, this one. You run this one. You don't necessarily have to retrain after you train these guys. When you jump down here, you can run this cell over and over and over again. But that's just what you have to get used to. So this is a full notebook that gives some graphics on how the model's fitting to the data, and then how we export it. We convert it to TensorFlow, and then I copy it back. This is the protobuf. This is the converted TensorFlow model back into the Unity directory for you, and then there's like a summary if you want to look at that. So when you open up the project, when you see the Unity, it has the spawner, and I'm not going to go into a lot of detail on this. I will on other videos, but basically what's happening is, as you can see, when it starts up every time, we rewrite this file, and we also put the columns in the file. That wasn't happening on the previous guy's example. He had his frozen model. We don't do that anymore, and he's loading it from a resource. So we're literally going in, and there's our model, shop model, protobuf. We load it, and then I make a decision, or I check to see if it loaded correctly or not. Sometimes it won't, and you have to go into C# code. I've got another video on the OpenCV that has my little Deep Lab C# program, and that's what I used. I'm going to have code added to that to show how people can basically dump the contents of the model, so you can see the node names, and if you don't match things up right, things won't work. So it won't load into TensorflowSharp correctly. So we have two different versions the way the thing runs. This class is a singleton because the ball controller, every time a ball is created, we are setting its force, and we need a way for the I changed the guy's code to where we're calling back from the ball to the spawner to report out, and the ball spawner controller is the one that manages the file. So you could see right there we're appending the distance and the force to the CSV file. So do shoot TensorFlow. He's got this aim. Look at these two transforms. So we're always going to be pointing at the goal. We're always going to be pointing at the goal. The only thing we're going to change is the force that we apply to the ball. So this is some of his original code. He does normalization, magnitude, calculates the closeness, and in here is where I've been playing around with some values to try to get the thing to work right. The G4, the force from TensorFlow is what gets called here. When we're running in this loop, we're running off of the model. We're not training. This is the coroutine that's running, and you can see he's got direction X, force, direction Y, the shot arc. I'm not sure why we need that, but we're set. We create the ball, and we set its distance, and we set its force. And the thing is that as the ball is flying through the air, if the ball does actually go through the trigger, and if it makes it, then we basically call the function. Probably should send a message, but anyway, on the ball spawner controller, and say, hey, this is the distance that worked, and this is the force that worked. So the balls are remembering where they got shot from and what the force is, and that's what gets logged. Okay, so this is the really, basically the TF sharp part, which is cool, is we get our runner. We can see the old, this is kind of the black magic stuff here. When you create models in Keras and you have your input layers and you got to know your output layers, well, you got to know what the names are. So it looks like Keras always adds something called an output underscore node, but you can potentially rename this so you can find it, because this is the call you got to make. This is the call you got to make to put some data in, and we're basically putting in, hey, this is the distance, and we're fetching what is the force, and that's what was modeled. And as you can see here, a recurrent tensor, a float array. This gobbledygook in here is part of the TensorflowSharp API, and you just have to know how to do this, and that's why I think this is a pretty cool example. So you don't need the ML agent or anything like that. It obfuscates all of this stuff. It obfuscates TensorFlow, Sharp. You don't really know what's going on. Some values magically show up, and they have a PPO model that's extremely complicated, but does some pretty cool stuff. But if you want smaller models that are just following curves or sinusoids or some other kind of simple behavior, and you don't want to have to code that behavior, and you just want to fit that behavior to data, I think this is a cool way of doing it. So here's the random shot. When we're training, it's almost identical code. Differences is we move a random distance, and then we get a random, we move the cube randomly, and then with that distance we randomly get a force, and then everything else is almost the same thing. I'm thinking about changing this code to where it deals with having a angle, a distance, and then an angle, and then a velocity. That's what I'm a little bit more familiar with. This is some code out of another project that basically does the same thing in a 2D game, and that makes a little bit more sense to me than this, having the X and the Y with closeness into this equation. It just, I'm not that good at linear algebra, and I'm learning about how to build these models, and I just need some things a little bit simpler. So anyway, been rambling. I notice I've got some more subscribers, and I know I'm off on a little bit of a tangent on the robot stuff. I am still working on that as well, but this I thought I could get this posted, make a video, get the code semi-working, and it's all in the same vein of using TensorFlow and Unity and having robots and things like that working in the same world. So anyway, I just post these videos raw. I don't edit them or anything like that, so bear with the large screen and the chitty chat stuff. But I think this is a great project, and I think the guy that originally created it was brilliant, and it helped me really understand how to fit linear and non-linear models to data using Keras. It makes much more sense in the Unity world doing this as opposed to learning how to do data modeling with the prices of houses. I don't really care, but what I do care about is cool 3D graphics and deep learning models inside of Unity. So I hope if you've gotten this far, thanks so much for watching. I'm going to try to do some more videos on how this particular thing works. I can already see a potential pool game coming together for using something like this, as well as building simple models, TensorFlow models for locomotion, for robot control and things like that. So this is definitely along the lines of what I'm interested in. Hopefully you're interested in, and I hope you get something get something out of it. So I'm gonna upload this. Hope you enjoyed it, and have a good one.